In this lecture, we're going to talk about solving inequalities. Before we start talking about inequalities, we want to talk about using interval notation. The first kind of interval that we have is called a closed interval. It's written square bracket a, comma b, square bracket. This means that a is less than or equal to x is less than or equal to b. Another type of interval is called the open interval, which is written open parenthesis a, comma b, close parenthesis, and it means a is less than x is less than b. So the open interval represents all numbers between a and b, but does not include a and b themselves. And then we can have half open, half closed intervals, such as open parenthesis a, comma b, square bracket, meaning that a is less than x, which is less than or equal to b, or square bracket a, comma b, open parenthesis, meaning a is less than or equal to x is less than b. So when you look at the interval notation, the numbers tell you the endpoints, and the symbol, open parenthesis or square bracket, tells you whether or not those endpoints are included. Here's a list of some of the different types of intervals that we may encounter, along with their corresponding inequalities and what their graph would look like. Remember, when we're dealing with intervals, you always write them in order, low number, comma, high number. Let's do some examples where we'll practice writing inequalities using interval notation. The first that we want to rewrite is -1 is less than x is less than or equal to 5. We start by writing the low number, -1, and it has an open parenthesis beside it because it was not included in the inequality. So open parenthesis, -1. Next we write the high number, which is 5, and it has a square bracket because it was included in the inequality. There was an equal sign on its inequality. Let's try writing the inequality x is greater than 1 using interval notation. Again, we'll begin by considering what our low number is. So the low number is 1, and we'll write that with an open parenthesis since it is not included. And there is no high value listed in the inequality. So there's no upper bound, which means that this will go to infinity, and infinity is always written with an open parenthesis. Let's do some examples where we're going to write inequalities based on the interval notation that was given to us. Let's start with the interval open parenthesis 1, comma 2, open parenthesis. Now, because both numbers are paired with open parentheses, we know that we will have strictly less than signs, and we just need to write the numbers in order from low to high. So this inequality would be 1 is less than x is less than 2. Next, let's try square bracket -8, comma infinity, open parenthesis. Again, we want to write this in terms of low to high. We were given that -8 is our low number, so we know -8 is less than or equal to x. We use less than or equal to because there was a square bracket. And there was no high number in the interval. We had infinity, so we won't put anything on the other side of the x. Let's talk about some properties of inequalities which may be useful when we're solving inequalities. For real numbers a, we know that a squared is greater than 0. We have the addition property of inequalities that says if a is less than b, then a plus c must be less than b plus c, and if a is greater than b, then a plus c has to be greater than b plus c. And we have multiplication properties. If a is less than b, then ac is less than bc if c is positive. If a is greater than b, then ac is greater than bc if c is positive. If a is less than b, then ac is greater than bc if c is negative. And if a is greater than b, then ac is less than bc if c is negative. Basically, what these properties say is that multiplication or division by negative number will switch the inequality sign. And finally, we have the reciprocal property that says if a is less than 0, then 1 over a is less than 0, and a is greater than 0 if and only if 1 over a is greater than 0. So let's do some examples where we solve inequalities. We want to solve the following inequalities and write the solutions in interval notation. First, we have 2x minus 2 is greater than or equal to 3 plus x. We want to get all of our x variables on one side of the equation and all of our constants on the other, so we'll start by subtracting x from both sides of the equation. This gives us x minus 2 is greater than or equal to 3. Next, we'll add 2 to both sides of the equation, giving us x is greater than or equal to 5. So, if x is greater than or equal to 5, we can write this in interval notation. We'll use a square bracket with the 5 since it's included, and the interval will say square bracket 5, comma, infinity, open parenthesis. For our next example, x divided by 3 is greater than or equal to 2 plus x over 6. The first thing we'll want to do is find the least common multiple of the denominators so we can multiply and remove our fractions. So the least common multiple of 3 and 6 is 6. Let's multiply the entire inequality by 6. We multiply the entire inequality by 6. The left-hand side simplifies to be 2x, and when we distribute the right-hand side, we'll get 12 plus x. Now we want to get all of our x's on the same side of the equation, so we subtract x from both sides of the equation, which leaves us with x is greater than or equal to 12. We're now ready to write this in interval notation. Since x is greater than or equal to 12, 12 will take the low spot in our interval, and it will have a square bracket with it. And there was no number bigger than x, so we will leave infinity as our large number in the interval. For our next example, we have 3x plus 4 is greater than 5x minus 6. To get all of our x's on the same side of the equation, we'll subtract 5x from both sides, giving us negative 2x plus 4 is greater than negative 6. We subtract 4 from both sides of the equation, giving us negative 2x is greater than negative 10. Finally, to solve for x, we divide both sides by negative 2, and that leaves us with x is less than 5. Notice that since we divided by a negative number, the inequality flips sides. So it used to be greater than, now it's less than. So we have x is less than 5. We can write that in interval notation. Since x is less than 5, 5 will be the high number in our interval. We'll write that on the right side with an open parenthesis since it's not included. And we don't have a number that's less than x, so we'll leave the left-hand side to be negative infinity. Now let's take a look at combined inequalities. This is where we have two inequalities written in the same expression. So for example, 4 is less than or equal to 2x plus 2, which is less than or equal to 10. To solve a combined inequality, we can break it up into two problems. First, 4 is less than or equal to 2x plus 2, and secondly, 2x plus 2 is less than or equal to 10. We can solve these two inequalities separately and then combine our answer. So for 4 is less than or equal to 2x plus 2, we'll subtract 2 from both sides of the equation, giving us 2 is less than or equal to 2x. To get x by itself, we'll divide both sides by 2, yielding 1 is less than or equal to x. For 2x plus 2 is less than or equal to 10, we'll subtract 2 from both sides of the equation, giving us 2x is less than or equal to 8. To solve for x, we'll divide both sides by 2, yielding x is less than or equal to 4. If we want to write this in interval notation, we know that 1 is less than or equal to x, so 1 is our small number. That will go on the left side of our interval with a square bracket since it's included. And we know that 4 is greater than or equal to x, so 4 is our big number. That will go on the right side of our interval. It will also be represented by a square bracket since it is included. And so our interval will be square bracket 1 comma 4 square bracket. And we need to check and make sure that this makes sense. Remember, when you're writing your intervals, the smaller number has to come first. If it doesn't, you've made some kind of a mistake. So since 1 is less than 4, this checks out. And for our final example, we want to look at 0 is less than 1 over 3x plus 6 is less than 1 over 3. Sometimes it's not necessary to break up your combined inequality. You can actually solve it all at the same time, as long as you do the same thing to all three parts of it. So we want to first multiply through by the least common multiple of our denominators in order to get rid of the fractions. So if we look at our denominators, we have 3 times x plus 2, and we have 3. We multiply all three parts of the inequality by the least common denominator, 3 times x plus 2. And we see that a lot of terms cancel out when allowing us to simplify. So after the terms cancel out, we're left with 0 is less than 1 is less than x plus 2. Now 0 is always less than 1, so we're not going to worry about that part of the inequality. We just want to solve 1 is less than x plus 2. We subtract 2 from both sides of the equation, and we're left with negative 1 is less than x, which if we write in interval notation will be open parenthesis negative 1 comma infinity, close parenthesis.